Okay, dear students, welcome to my third class on electromagnetic theory. Today we are going to discuss the next operation of del into a vector function into a vector quantity. Del can operate upon a vector quantity through dot product, then the resultant is known as the divergence of that function. That is, divergence of the function is del dot f, where f is a vector function, or simply we call it as div f. You see how del operates upon f through dot product. That is, del operating on f through dot product, or del dot f is equal to I dou by dou x plus j dou by dou y plus k dou by dou z, taking dot product with I fx plus j fy plus k fz. The resultant will be, you know how to take a dot product, I dot I, j dot j and k dot k term remains and all the other terms will be vanished. So I dot I, that is I dot I dou fx by dou x plus dou fy by dou y plus dou fz by dou z. This is a resultant of del dot f, or del vector operator operating on another vector function through dot product. The resultant is dou fx by dou x plus dou fy by dou y plus dou fz by dou z, which is obviously a scalar. That is, divergence of a vector function is a scalar. So then we will see what is the physical significance of divergence of any function. Divergence of a function is actually a measure of how much this function f diverges out from a point in question. How much the function f diverges out from a point in question. That is the divergence of a function f. Or we can also define it as the net outflow, or it can also be defined as the outflow minus inflow. Outflow minus inflow. I will explain. That is, consider a faucet. You have seen faucets. The water will be entering into the faucet, which will be flown out through like this. That is, inflow will be like this and the outflow will be like this. You can clearly see that in this, outflow is greater than inflow, or outflow minus inflow will be a positive quantity, and this is an example of positive divergence. This is an example of positive divergence. Outflow greater than inflow. Then all the faucets are showing positive divergence. Then we will see a case of negative divergence. That is, inflow will be like this and outflow will be like this. Here you can see that net outflow, or outflow minus inflow, will be a negative quantity, and this is an example for negative divergence, and they are called as sink. A sink is an example for negative divergence. Then there are cases for zero divergence also. That is, inflow will be equal to the outflow. Then such cases are known as zero divergence. This is the physical significance of divergence. Is a measure of how much a function f diverges out from a point in question. This can also be defined as the net outflow, or outflow minus inflow. There are cases of positive, negative and zero divergence.